minimum time length, and I want it to be able to upload the video while another one is still recording. Because I found this to be best. All right, a couple announcements before we dive into the week. Hazel is an elephant now. Hello, Hazel. So, a couple. Hey, up here. Unless you're putting a name on a paper or getting something out or putting something away, I should have your attention. Right, Audrey? Yeah. Thank you very much. So, the next 3 worksheets for this week are right here. They're blue. The green worksheets from last week are due by tomorrow. Some of you have already sent them in. Please make sure you have all 3 that go in the batch. If you turn in 2 of them, I will give them back to you and say, try again. Because we're learning how to collect things that go together and turn them in together. Simon, what's up?
You said this was 2 days worth of practice, but in the Tuesday slot there's another blue thing, so would that be...
Oh, yes. Oh, he did now. Come on, man. You know how my brain works. I'm just like, the next day. So, yeah, that would technically be Wednesday's homework. But tomorrow, I'm out. Nothing concerning about. I'm just out in the afternoon. So when you see me in the morning, don't be like, wait, but you're not here today. I will be here tomorrow morning, but I will be gone in the afternoon. So depending on how far we get today, tomorrow's just a work day for you. So being that your green homeworks are due by the end of the day tomorrow, don't put them off, but you could spend that time on those tomorrow, and or this worksheet, or the next 2 blue worksheets, or, I should be saying and or, by tomorrow, I should have the rest of the worksheets for this chapter back. Those will be orchid because people voted on that, the people that were here early. So I will have the guest teacher have those available for you. If you are done with this worksheet then you got for today, and you finish the next blue worksheets, you'd be really far ahead. But if you get that far ahead, you can work on the next ones. We will be finishing Chapter 8 and taking the mastery by next week. Chapter 8's faster. So we will be doing that by next week. And today, we'll likely, for some of you at least, feel like, wait, we already know this. Because some of you, probably your 7th grade teachers, did teach it to you, although it's really an 8th grade standard. So, anyone want to read? Starting with earlier, we just got a paragraph to read. Audrey, go ahead.
Earlier in this chapter, you worked with expressions for interest problems. You could rewrite them in simpler ways by using multiplication in place of repeated addition, and by using exponents in place of repeated multiplication. Rewriting expressions in different forms can be a powerful tool for simplifying expressions and seeing patterns. In this lesson, you will develop strategies for how to rewrite expressions using exponents.
Did anyone catch the bad joke?
No.
Nobody?
Was it the powerful?
It can be a powerful tool because exponents are also known as powers.
I think they wrote that.
I hope so. If I was one of those writers, I would have laughed myself all the way home thinking this could be a powerful.
There's something they say for everything, even the giant one, which is useless.
It's not useless. It's actually very, very useful. But the nickname of it is not necessary. But be careful saying things are useless. That's rude. So, I know you've all been so sad over the weekend when you spent time away from me in the anticipation of being called from random cards. So here you go. To your heart's biggest desire, Audrey, way in the back, is 3 with... Okay, why?
Because it's 3 times 3 times 3 times 3 times 3. No, one more. Times, no. Times 3. Oh, never mind.
But what is this?
No. Not the same thing.
What is it?
What do you mean?
Why is it 3.5? What is it showing me? Alina?
So, the square is, like when you square it, it's multiplied, but when you multiply it, it's...
You now be careful, is that squaring?
No, it's not, sorry.
So that's an exponent. It's a power, but it's not squaring.
Yeah, it's...
Squaring is when it's 2.
You're like, yeah.
But this, what does this represent? represent, Avi? Repeated addition. So that's 3 plus 3 plus 3 plus 3 plus 3. So not the same, right? Exponents are just repeated multiplication. If you need to write something down to remember that, please do so now. So, which is the first one that I have? Yeah, this is in your paper. So, on your paper, if you needed to write something down, the last problem we just solved is up here. But go ahead and fill in this table. Yeah, on here, on your blue paper. So the little number is called the exponent or the power. They do not mean anything different than each other. But the thing I need you to know is the big number. Anyone know what the big number's called? The base. So the big number is the base, whereas the little number is the power or the exponent. So the base is the number that's being acted on. The exponent tells you what's happening. So this, to start, is 2 times 2 times 2 times 2 times 2 times 2. How many 2's in total?
6. Too many.
So 2 to the 6th. 2 many.
Yeah, you just add the you add the two exponents together. We were taught this on Khan Academy. Speaking of which, are you gonna do classes?
Simon, I think you're the one person still remembering that. And I do want to. This year's just become so chaotic.
No, don't make
Like,
us know.
I appreciate you keeping me honest about that. I will by the end of the year. Know that more things have happened to me / my household this year than any other teaching year. So things have just been chaotic. Just taking care of my dogs and everything. We've just been really busy.
Oh yes, the dogs.
So
The dogs.
Simon is saying there's a quicker way. There's a trick, quote unquote, a trick here. So like x to the 3rd times x to the 5th, we could write out xxx plus, or not plus, times xxxxx. Or, Simon, what are you thinking?
Oh, so you notice that you just add the two exponents together.
This really, and I would like you to do this on your paper, the power adds the exponents. Now here's what messes people up. Here's your trap door. This is multiplying the bases, or really like the two different values, but the powers add with each other. So a value times another value, the powers add, and this becomes x to the 8th. But we're going to see another situation. What if this, do not write this down, do not solve this right now, I'm just trying to give you something to think about, was x to the 3rd to the 5th. That is different than this. Okay, we're not doing this right now. We're not doing that right now. I just wanted you to think about that. Now, what happens if we have two different bases? Katie Ann, what do you think?
Two different bases? I think
Yeah.
I think that you would. I gotta think of this one for a second.
Can I put my x's with my y's?
No.
Not really, right? They're not like terms. So this really is x times x times x. And this really, please write out the expanded form with me, is y times y. Times, how many more x's? One more x. Careful, that's why we're writing this out. This is only 1x. It does not get the power that the y gets. So then the other y is y times y because it's y squared. In total, how many x's do we have? 4. So it's x to the 4th times how many y's do we have? 4. Ooh, yeah. Which we could write as x, y to the 4th, but you don't need to.
X times 4, not x.
because that tells the x to be raised to the fourth and the y to be raised to the fourth. That's x times y to the fourth. What rule is it, Josh, that allows multiplication to be rearranged, like the order to change?
It doesn't affect, because like 7 times 4 would equal 28.
Yeah, what rule is that though? Do you remember the name? So it's the C. You found a friend. What? Yeah, the commutative property tells us that really in our head we can just think about moving things to the to buy the like terms. So if I move my 7 with my 7s and my x's with my x's, how many 7s do I have in total here? 3. So this is going to become 7 to the third times x to the fifth. Now 7 to the third, we could actually figure out 7 to the third, but notice this says exponent form, not just straight up simplified form. If it said simplify all the way, we would do 7 times 7 times 7.
Yeah, but that would take
It's only like 243.
So the reason it's 7 is because a base number is just the number to the exponent of 1.
Yes, so a general standard number is just to the first power. So 7 is just 7. Not 7 times 7, because that wouldn't be 7. So any number that is just itself, I'm not a freak. I've just done this enough times. I know what 7 cubed is.
What is it?
243. Which is what Xander's trying to show you, is that I'm some weird freak and I knew 7 to the third.
That's exactly what you are. Never seen anyone make that computation that fast.
I didn't make the computation. I just know it.
You know what I'm saying.
So I could ask you something about basketball that you would just know because you know it.
Maybe.
You wouldn't have to like think about it. I just know 7 to the third.
Yeah, my dad's friend memorized all of the 2 squares up to like 22 to the 23rd.
Now hold on, this might blow Xander's mind. It might actually bring him back down to not mind blown. So Xander, come with me. What's 7 times 7? 49. 49 is really close to what number?
50.
What would 50 times 7 be? We can do that pretty quickly, right? 250.
Wait.
Or is it 350? No, it's 343. I was off by 100.
I saw that on the calculator.
Yeah.
At least he knew the last 2.
It doesn't matter. He still got it.
So here's how you remember the end in 3. No, hold up. Here's how you remember the end in 3. Guys, this is Common Core math at its base. Watch. Like, these aren't crazy things to think like, oh my gosh, how'd they do that? Imagine this is 50. Do 50 times 7, that's easier. It's 350. Minus, this is not 50 by 1. Right? So minus 7. So this becomes 343. That is 7 to the third power. And what do 4 and 3 add up to? 7. So number tricks in your head. So try this bottom one on your own real fast. Try this bottom one. I bet you get it wrong. No, not really, actually. I bet you get it right. Actually. Just be careful. They're trying to trick you because it is unlike the other ones in a small, tiny way. Not really a trap door. Logan, do you see what's different than the other ones that we've had?
Yeah. Oh, I'm not Logan.
You're not Logan.
The first term does not have an exponent.
Yeah, and not only does the first term not have an exponent, it doesn't even have a partner. Like, there's 2, but there's no other times 2s, right? There's a times 3. Can I put excuse me, the 2 and the 3, sure, but I just get 6. So that is going to give us 6. How many x's, Logan?
5. Wait, shoot. I'm dumb. 5.
X to the 5th, and then how many y's?
2.
Yep, just y to the 2nd. So our simplified form is 6x to the 5th y squared.
How'd you get that? So just
How'd you get what?
take the multiplication sign out. How would it be x to the 5th? Because we have the 4. Because we have the 4.
It'd just be x.
We have x to the 4th.
It'd be x4, right?
It'd be x.
You want to explain it?
You want to calculate it?
X comes from the xy squared at the end.
Yeah, but then that's squared, so it'll be.
Remember, guys, this is why I said this is a trap door. Give me your attention, because I bet a lot of you are like, oh, I get it. But you really, you're missing one key component. When we have terms written with each other, we're abbreviating the math. So 2x to the 4th is 2xxxx, 3xy, y. And I could actually get rid of this dot, and it means the same thing. But when terms are right up against each other in math, assuming we're not talking about a number that is like 23, because obviously the 2 and the 3 are not 23 here, this is assumed, assuming is dangerous, it's assumed multiplication, all of it. So there's multiplication here, 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 and multiplication is commutative. The 3 comes out here to join the 2. This x comes over here to join those, and the y's stay with each other.
So, there's no parentheses, so it would automatically go for the y.
The square right here is only on the y. The x gets a power of 1 because it's just x. Because that's really x times y squared. They're just not showing the times. This is where you got to be careful. It's all just multiplication. They're not they're not stuck with each other. They're just connected for now. Patrick?
How do we know that xy is its own separate variable?
Because then it would be xy squared. Like it would be grouped together.
No, I mean how do we know it's not its own separate variable?
Because we don't do that. Remember last week when we talked about we don't use 2 letters as a variable? We don't do that.
The third variable would be z.
Literally took the words right out of my mouth. If we were going to say xy is a variable, we would introduce a new variable, and instead of using xy, we'd say z or something else. A single letter. And then off to the side, we would just say xy is z. And from that point on, we just use z. But we don't use 2 variables as a variable. We don't. We do not do that.
Good afternoon, Araya Scarver. Please come to the remote office. Araya Scarver, please come to the remote office. Thank you.
Every class today. If you
Would
want,
would the fourth variable be a?
There's no particular order. Generally we go x, y, z, and then people just do whatever they want. I'm sorry. I know you want a better answer than that, but there's no particular order of what variables we use. Simon? Oh, pause. And sometimes we use Greek letters so that we're not even choosing American letters. We use Greek symbols instead. So, yes.
But don't we use delta for smudge?
Yes. Some of them are isolated too. We can only use them for specific things. Other things we use for whatever. So, Henry, not to overteach too much, but this symbol that looks like an Easter egg is the Greek symbol theta. It's often used for an unknown angle measure. It doesn't do anything mathematical, but this symbol has a mathematical function it does. Yes, it is on my shirt. So that we can't use as a variable because it does something. It actually sums everything after it. Yes, it is sigma. We heard you all 5 times.
if you run out of letters,
Selena. You are correct. We use theta in trigonometry.
I didn't. I learned it in the math test. Well, I did learn it.
So look at C. Actually, look at B first.
Good afternoon, Gwendolyn Armstrong. Please stop by the remote office. Gwendolyn Armstrong, please stop up by the remote office. Thank you.
Look at B real quick. Do not talk with each other for a second. We have, don't talk with each other or yourself, I guess. Just don't talk. If you had 20 to the 12th times 20 to the 51st, checking random cards if people understand, not here, Ike, what would that become? 20 to the 12th times 20 to the 51st. You can always pass. I'm just random carding to get people involved. Hazel, what are you thinking? Ooh, absolutely. It is 20 to the 63rd because this is 12 20s multiplied by each other. So 20 times 20 times 20 times 20. You want to really annoy your parents or siblings or somebody, be like, hey, do you want to understand exponents? X to the 20th is X times X times X times X times. Yeah, you'll really annoy them quickly. So then 20 to the 51st, buckle your seatbelts for that one. It's 20 times 20 times 20 times 51 times. We're not going to say those. We're going to write it like this. Now, Elena, one study team looked at part C and they're like, oh, well, yeah, that's just 50 to the 7th because we put it all together.
Nope, doesn't work like that.
Elena, what are your thoughts on that?
No, but I don't think it works like that.
Why?
Because you know, like the exponents aren't the same. Therefore, if the exponents were the same, that could be possible.
If the exponents were the same? Please write this down somewhere. Exponent values only combine when bases match. So not when the powers match, but when the bases match.
Basis is the bigger number.
Yep, it is the bottom.
Basis versus bigger number. Well, bases aren't always the bigger number. Bigger in
It's the
actual
thing
size.
being raised to the power. And yeah, when we write it, it is physically the larger, when we, like font size.
Yeah.
Not numerically larger, but font size larger.
I thought, okay.
I'm with you. I know what you're good now. The larger font number. Yes.
Does the commutative property have anything to do with communism?
I don't know. I'm not even gonna try to comment on that.
Comment on what?
Alright, so speaking of commutative property, we know, I'm gonna assume a couple things here. I know that's dangerous. But we know 2 times 10 is the same thing as 10 times 2. And if I can't assume that, you might be in the wrong class. So we know that. But 2 divided by 10 compared to 10 divided by 2, I wonder if these things are the same. So wait. How in the world does that relate to exponents? It doesn't, you say. Logan, thoughts?
First things first, so let's say it's like x to the y. You can do like x to the power of y, but it's not the same thing as y to the power of x. In some cases.
Ooh, okay.
And also like, isn't it
So
like,
you can't just like flip locations.
like I don't know,
totally
if
agree.
you like do like the power of like a number less than 1, doesn't it do like division sort of? Maybe a negative number, I don't know.
We talking about negatives in the power
Yes,
or negatives in the base?
in the exponent.
That'd be interesting. You might need to play with those. Audrey, do you have something? Leo? Simon?
All right. So I think it's so if it was an exponent being divided by something really improvising this. If it was an exponent being divided by something else, you would find the square by dividing the thing.
Now, we're not even there yet, but Simon's already got his brain thinking. What happens when we divide with exponent values? So factored form.
Oh, it's squared. Or sorry.
Hold on. Factored form. You might need to write this down because this is what a lot of kids, when it comes to a test, are like, wait, factor? How do I factored form? Just means broken up. So you might want to write down factored literally just means broken. To factor something means to break it up. Factored means broken. So factored form of this expression is to break up that 5 squared is 5 times 5. And that x to the 4th is x times x times x times x times 5 times x. That is the factored form of that expression. And remember, it's an expression because it doesn't have an equals.
Then couldn't it just be 5 to the 3rd times x to the 5th?
Yes, that is what it is. And we can reason our way to believing that after we factor it and say, like, oh, yeah, well, that makes sense. Because now we can see there are 3 5s, there are 5 x's.
My arm got factored one time.
Probably actually fractured. No? Okay. Yes.
So, just a question about the homework. Would you rather us turn in homework late or turn it in on time, but not have all the questions be correct?
I never really care about all the questions being correct. I care that you took time to engage with it and tried your best.
Oh, no.
So I'd rather it be done, correct or not, that like you tried your best and on time.
I'm not sure I've ever gotten a homework question right.
You're funny. Liam?
Why would we break an equation? It doesn't make sense. Why would you factor it?
No, we break
Trust
it because
me,
it makes everything
it's
easier.
gonna come in handy.
Yeah, Liam, it's gonna come in.
Do you understand what it means now? I haven't yet sold you on why you care, but do you understand what it means to factor? That's all. I don't need you to believe me that we need to do it yet. Selena?
Because you need to like factor, did I say factor form? Yeah, you need a factor form because once you like factor form into like a certain degree, you can like simplify it
Yeah.
to like a different thing. It's like algebra works that way.
Yeah. And
I
math.
like this.
Yeah.
Yeah, math.
Scientists consider
That math.
help.
So, notice they don't ask us to factor things out very often because factoring makes it longer to write. So here we have 3w cubed, 3w squared, 3w, and 3. So in simplified exponent form, how many 3's do we actually have?
4.
Yeah, sorry, that was kind of a trick question because that one doesn't count. So 3 times 3 times 3 times 3, we have 3 to the 4th. How many w's do we actually have?
5, 6.
6, because this is w to the 1st.
Yeah.
So it'd be 3 to the 4th, w to the 6th. You don't have to write this down, but does anyone have any questions?
Possibly, no. Maybe. I don't know.
Try the next one on your own. It's on your paper. Yeah, it is. 39.
Oh, it's right here.
Hey, where's your blue sheet? We've all been answering questions on them. I've referenced it multiple times, and this whole table should be filled in. Xander's at least got some of it. Charlie's got all of it if you want to copy off someone. I'm just making observations.
I was just going along with I am done. I am late today.
That's not what we're doing right now. We're done. So, this now has led us into something new. right? This isn't like using variables. And those powers here are on tens. So 9.23 times 10. Oh, wait, just times 10. Okay. 92.3. Fancy pantsy. 9.23 times. I should really do the math.
So we have 923. We have 9,030. We have 92,000. It's easy.
Oh, E-word.
It's ease. Not easy.
It puts you at ease when you do it.
Now wait, somebody shouted something out that made it seem like they already had a trick devised.
I did.
Is that a hand or no? Al, what do you think? Ellie, sorry, I know that too. What? I know there's too many of you. Look, when we came back from winter break, I felt so bad that I'd forgotten about half your guys' names. Not like permanently, but it'd been like 2 weeks. What? Huh. Look, y'all learn 6. Count them, maybe 9 if we really, maybe 10 if we give you like office staff and everything. We learned 86.
I know
86
all
names.
Now, listen, the question is, if you get to learn one name at a rate of 1 name per minute, how long would it take you to learn 86 names?
That's not a very hard problem.
1 hour, you would.
Ellie, my apologies. Sorry, I got yelled at for calling L Pasquinelli L-E because it's not L-E because L-E Pasquinelli is too fun to say and she definitively goes by L. So my brain just short-circuited. I'm sick like, so L-E, my apologies. What's
Elevated.
we could really emphasize it L-E. Alright, so what's the trick?
You just move it up the number of like the exponent's place value.
Whatever the exponent is. Now, does this work for any number? No, it doesn't. The exponent on a 10. This is called scientific notation. It's a weird one, guys. So, you might on your blue paper right here above those numbers write the word scientific notation to put it in your brain for a first time or not or not a first time. It's okay if it's not your first time. Wow. So now here's a cool thing that your teachers previously maybe didn't tell you. The reason we use scientific notation is to talk about values that would be ridiculously hard to talk about otherwise. Like the distance between here and Mars in feet. Or the distance between molecules in feet. Right? Like really, really, really big versus really, really, really
No, but it's not about the numbers.
Henry?
I'm glad stabbing
Sorry, his
myself
hand
in
was
the
up.
armpit got your attention.
I did not see you stabbing yourself. That will never get my attention. I would just tell you to go to the nurse at that point.
Okay, so if the so does scientific notation always have to be 10 by a power, or can it be other numbers as well?
Ah, wonderful question. It is always times 10 to the something. Now that doesn't matter if it's a big number or a small number. It's always times 10 to the is how people say it. It's times 10 to the whatever.
Second.
Hey, people shouting things out. Notice that there are a couple hands raised. Xander.
Okay, so would sometimes the exponent end up being like a decimal then?
No. So the exponent, not in scientific notation. Here's why. The point of scientific notation is to take a value we already know and just write it better. So if you, in your calculator, especially if you grab a fancy calculator, type in some big numbers. And like, have you ever just been playing with a calculator and you're like punching things in times, whatever, times, and like all of a sudden, either your calculator like shoots up some smoke and smolders itself into a pile of ashes, or it like spits out an error, or it gives you some answer either times 10 with some little number, or it has an E in your answer, and you've always been like, ah, ha, 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 I didn't even know what I was doing, I don't care. That's your calculator saying, I can't fit the answer on my screen, right? A computer could fit as big of a number as you want, but your calculator can only fit so many digits. So we use scientific notation to fit really big numbers in small spaces. So, hold up. We need to answer these really quickly. So this tells us move our decimal 2 places positively, which means to the right, and this gets bigger by 2 decimal places, and it comes out to be that. Please write it down. Just make me happy. At least fake that you're writing it down. Like look down at your paper and move your pencil for a second. Now, when you have a number bigger than the amount of places we're able to move, quote unquote, it doesn't matter. We just add zeros. So this is going to become 3, 4, 6. I move 1 decimal place. I move 2 decimal places. I move 3 and a 4 and a 5. Then I drop my decimal. So that is here. Then we put in our commas. It is 34,638,000. This right here. It's 34 million. Simon.
Just so you know, you can't really fit all that on your computer. I tried pasting entire articles into Google and it doesn't work. It gives you an error message.
Well, okay, fine.
Well, it's called Notepad.
Use Notepad.
Don't use Notepad.
So, why did we invent this? Mathematicians and scientists, they're kind of lazy, but not in a bad way. Like when when your parents are like, quit being lazy, clean your room. They're lazy in the way that why do work we don't have to do? Why write something we don't have to do? Why type something I don't have to it just doesn't make sense. Hey, so lazy isn't necessarily bad. Lazy is how most inventions have been made, right? Why would I
Light a candle when I can turn on the lights.
Yeah. Now, lighting a candle would involve, sparking 2 stones off each other and a whole process. But the reason is a lot of these big numbers, we don't care about some of the smaller digits. If you're talking about the distance between here and Mars in feet, you don't care about an extra 7 feet probably. Now, if you're solving a really complicated problem, you might, but they start to drop what we call, what digits don't we talk about in scientific notation?
All of them. Probably a tiny decimal point.
No, what do we call them? Because if you know this, you can just
Significant figures?
So if you're with me, I could call on you and you could help engage in our conversation, but I have no idea what you and Xander are talking about, but I bet Xander can't answer my question.
I'm trying to listen.
I know. And what I'm trying to get Logan to understand is he is negatively impacting your learning right now, which is rule number 1.
Don't hurt Sandy.
Wait, isn't that
Henry? We're not going there today.
Essentially, the only rule Estes and Kabila talked about at the beginning of the year, you can do anything you want as long as it doesn't negatively impact your learning or somebody else's. So please stop. The only numbers we care to write are called significant digits. Like your significant other. Significant digits are the important ones. Right? Your significant other is the important one. They're the ones that when they call you in the middle of the night, you're like, yes, dear, okay, fine. I don't know why. But the other numbers, what? Look, when my wife says, get me a glass of water, I don't say why. I just say yes. So this, I move it once, twice. These zeros are what we call, we'll go into this more tomorrow, but they fall into what we call insignificant digits, and that's why we only have three significant digits here. And I need my decimal place up there. Numbers like this, we wouldn't probably write out. That would be ridiculous to try to write out a number like that.
That's 30 zeros and one in front of it.
Well, 29 zeros, but good try.
No, wait. No, actually, it's 30 zeros. 28.
No, 28 zeros. We were both wrong. This 28 zeros on the right side of that number. We're out of time. Get out of here.